want to talk about earthquakes and the Richter scale very briefly. This is best watched after the decibel video. Here's a USGS website, earthquake.sgs. Looking at earthquakes last hour that just happened, the last day, and the last week. You can all look at lists, all the earthquakes in the world in the last week or so that had magnitude 5 or greater. Talk about is what does that magnitude measure? What's the difference between like a 5 and a magnitude 6.3 earthquake? Or what is the difference between that and, say, a magnitude 9 earthquake, like the one in Japan last year, or the one that caused the tsunami about 7 years ago, the biggest earthquakes? And what's the difference between these and a magnitude 2 earthquake? What would that mean? Well, let's look at this table. So here's some earthquakes, and I've put down the intensity, and this is the seismograph intensity. It's basically just how much does the needle go on the seismograph. It's in measured in centimeters, so we should put in centimeters on the seismograph. And that's very roughly, there's some real issues with saying what I'm about to say, but it's very roughly a measure of sort of how much energy is released by the earthquake. It correlates with how much acceleration you get on the ground, which is what causes buildings to topple. And the main thing is to notice that the largest quakes, like the Japan earthquake in 2011 or the Sumatra in 2004, those correspond to 10 to the 5th. Now, the centimeters, obviously your seismograph is not going to actually record that, but they can project that and say this is essentially the seismograph reading for that. 10 to the 5th, as opposed to the standard kind of minimal reading of a micron, a tiny little reading, 10 to the minus 4th. And even a minor quake, something you could actually detect with a seismograph, 10 to the minus 1. This is a very large range. And so, as usual, it's good to use a logarithmic scale to accommodate a large range of variation. Okay. So again, don't take the centimeters too seriously here. It's a very, very rough description that I'm giving here. So you've got the largest quake, 10 to the 5th. So we're going to just take the logarithm, the common logarithm of that. That would be 5. This would be 4. This would be 3. This would be 2. The problem with that is you're going to use negative numbers. Nobody really likes negative numbers unless they have to. So instead, we're going to do what we did with the decibel scale, is we're going to take these numbers and we're just going to always divide them by what we call S, the standard minimal reading. This could also be called I sub 0, the intensity of sort of the minimal thing you want to put on the scale. And this is basically what we're going to set to have magnitude 0. So we're going to take this and divide it by itself. We get 1. I over S is 1. The log of 1 is 0. So that's going to have magnitude 0. So this is really going to be the magnitude of the earthquake. 10 to the minus 1, if you divide that by 10 to the minus 4, you have to subtract the exponents. You get 3. So it's 10 to the 3 times. It's a 1,000 times more intense, in some sense, than the minimal reading. And so you get magnitude 3. Moderate quake, let's see, 10 to the 1 over 10 to the 4, that's 5. So a moderate quake, or if a small nuclear weapon, is in terms of sort of the energy released. A strong quake, oh, here, this one, the minor quake, I just looked up on that list, and turns out there was a very small earthquake, magnitude 3 earthquake, today, when I'm recording this, just a few hours ago, I think, in a place called Cartago, California. You can Google it if you want to know where it is. I didn't look it up. 10 to the 2 divided by 10 to the minus 4th is 10 to the 6, so you strip off the exponent and get 6. Then go up to 7, 8, and 9. So notice every time I go up a factor of 10, because it's a logarithmic scale, I just go up by adding 1. Multiplying here, adding here. That's the essence of logarithmic scales. So for example, if you have a magnitude 6 quake, and compared it to a magnitude 9 quake. Magnitude 6 is not something you want to voluntarily live through. It could really do some damage. Depends on exactly how well the buildings are built and what kind of soil it is. But that has only 1/1000th of the intensity of the largest quakes that we ever get, the magnitude 9 monsters. So the one in Japan is just tremendous, a strong quake in a badly built part of the world, or a place where there's no preparation in terms of the building for earthquakes. This could kill thousands of people, and then you've got something that's 1,000 times stronger going on in the biggest earthquakes. A very, very dramatic difference. A minor quake, so this is the kind of thing you can barely feel even if you're right there, is 1,000 times weaker than that magnitude 6 quake. Okay. And so again, the idea of taking your intensity, dividing it by a standard, and then taking the log is a very nice, very, very standard way of creating a logarithmic scale.